Logic 0, Chapter 11, Memorization of Operations. I wanted to give you some pointers on how to memorize the lookup table. So here's our lookup table. And I want you to notice a few things about the lookup table. So working through each operation. Negation flips the value of what is to the right of it. So if what is on the right-hand side is true, then it becomes false. And if what's on the right-hand side is false, then it becomes true. Notice that there's only two options for the right-hand input here. That's why we only use the first two rows of the lookup table to indicate the definition of negation. These last two rows are just a repetition of true false. So just be the same. So no new information in those last two rows, because this is just a monary operation. It only takes one input. So it's different than our binary operations that take two inputs. Those require 4 rows to get all the possible interpretations of left and right covered. So negation just flips the value. If it's true, what's on the right is true, then it becomes false, and vice versa. If it's false, it becomes true. Because we were using like evens and odds earlier on, sometimes students, and even if that approach isn't taken, students often think that maybe negation here is like adding a negative sign to an integer, like 3 becomes -3. It's like the opposite in some way, but that doesn't really work out. So if you think about it in terms of evens and odds, 3 is odd and -3 is also odd. But what we really want to do is we want to switch from 3 being odd to even, right? So it's doing something different than adding a negative sign to an integer. Okay, so conjunction. Notice the pattern here. Looking all the way down the column, the only time that conjunction is true is when both left and right inputs are true. And we use the English word and in connection with conjunction. And it says that the left-hand input and the right-hand input are true. That's what it's claiming. That's what L and R means. And so if either of them is false, then the conjunction is false. And that's all these last 3 cases. So for conjunction to be true, both inputs have to be true. With disjunction, this is or, and if either the left or the right, and even both could be true, if either left or right is true, then the disjunction is true. So this says left or right. Either the left is true or the right is true. If they're both true, this disjunction is true. If the left is true but the right false, it's true. If the right is true but the left is false, it's still true. It's only false when both are false. So that's something you want to look for. It's only false when both left and right are false. That's for disjunction. Material consequence, it's only false in this second case. So it's only false when the left-hand input is true and the right-hand input is false. When talking about material consequence, we call the left-hand input the antecedent. And the right-hand input we call the consequent. And the antecedent is anteceding or antecedent. Antecedent literally means what comes before or what comes up front, and consequent is what is consequent or is what follows consequentially from the truth of the antecedent. And so the key thing to notice in the pattern here in the truth table, in the lookup table, is that material consequence is only false when the antecedent is true, but the consequent is false. Otherwise, material consequence is true. If the antecedent is true and the consequent is also true, then it's true. And if the antecedent is false in these last two rows, if you see that the antecedent is false, it doesn't even matter whether the consequent is true or false. If the antecedent is false, the material consequence is true. So that will help to, speed things up as you're working through truth tables, and, these explanations just kind of help you have a different approach to memorizing the table here. Finally, we have the material equivalence. Basically, L, if and only if R, that's what this says. L, if and only if R, means that if L is true, then R is true, and if R is true, then L is true. So what it's saying is that their truth values match. And the truth values of left and right match in the first row. And so material equivalence is true. And they match also when both are false in the last row here. That's when material equivalence is true. And if they're mismatched, true, false, that's false, and false, true, that's false. So if they match, material equivalence is true. And if they don't match in truth value, then the material equivalence is false.